November 7, 1940. A cold, windy morning in Washington state. The Tacoma Narrows Bridge, nicknamed Galloping Gertie, twists violently in the wind, and then collapses into Puget Sound. What went wrong? And how did this disaster reshape engineering forever? Some failures are just so spectacular, so dramatic that they become more than just history. They become legends. And today, we're going to talk about one of the biggest. This is the incredible story of the Tacoma Narrows Bridge. We're looking at one of the most iconic engineering failures ever caught on film, and believe me, it became a crucial, if catastrophic, lesson for everyone. So how in the world could this marvel of steel and concrete, celebrated for his cutting-edge design, basically commit structural suicide? Designed by engineer Leon Moisseiff, it stretched nearly 6,000 feet across Puget Sound, with a main span of 2,800 feet. It was the third longest suspension bridge in the world when it opened in July 1940. So instead of using the traditional super deep and heavy 25-foot processes that let the wind pass right through, he used these thin 8-foot solid girders. It made the bridge way lighter, way more elegant, and way cheaper. And this is a huge but, it also made it a lot more flexible, and critically, it meant the wind couldn't go through the deck anymore. It had to go over and under it. So this crazy flexibility, it wasn't some hidden secret that just popped up on the day of the collapse. Oh no, from the very moment the road deck was put in place, the bridge started to move. And it moved so much it quickly earned a nickname that's now pretty famous: Galloping Gertie. On November 7, 1940, winds reached 42 miles per hour. The bridge began its usual undulations, but then something changed. The oscillations intensified, shifting from vertical waves to violent torsional twisting. Technical cause: aeroelastic flutter, a self-exciting vibration where wind energy amplifies a structure's natural frequency. Feedback loop: the bridge absorbed and amplified wind forces, creating uncontrollable motion. They tried to fix it again and again. Massive tie-down. Couples anchored to 50-ton concrete blocks? Nope, they snapped extra cable stays to try and stiffen it up. Totally ineffective. Brand new hydraulic dampers to absorb the motion? Yeah, those got damaged during construction before they even had a chance to work. It was one failure after another. Right around 10 a.m., that familiar galloping suddenly changed into this violent twisting motion. The entire road deck just started contorting with one side. By 11 a.m., the bridge tore itself apart. Fortunately, no lives were lost, except for a dog trapped in a car. But the collapse was captured on film, becoming one of the most iconic engineering failures in history. The Tacoma Narrows disaster revolutionized bridge design. Engineers realized they had underestimated the effects of wind and dynamic forces. Modern solutions: wind tunnel testing, now standard for all major bridge designs. Computational fluid dynamics, CFD, simulates wind behavior around structures. Stiffening trusses and dampers, added to reduce flexibility and absorb vibrations. Aerodynamic decks, designed to minimize wind resistance. Today, the rebuilt Tacoma Narrows Bridge stands strong, a testament to the lessons learned from its predecessor. The fall of Galloping Gertie wasn't just a collapse, it was a wake-up call. And thanks to that moment, bridges around the world are safer, smarter, and stronger. Thank you for watching. Drop your thoughts in the comments, click that subscribe button and share. Bye.